Hello. Hi guys, good morning. Welcome back to a new video. Again, you might ask, Aryan, every time is good morning. Yeah, for me, every time is a good morning. Again, we'll see again from very basic, optimal, like better, and then most optimal approach we'll see in this video. This is the last problem of the today's bi-weekly contest. Problem contest was 126. It's a very simple statement, but can be a bit confusing depending upon how we perceive it. Simply, it says that we are given an integer array called as nums of length n and a positive integer k. I have an array nums, I have a n length which I can easily derive from nums itself, and I have a positive integer k. Okay, now the power of an array of integers is defined as the number of subsequences with their sum equal to k. So if I say that, bro, if I give you any array with, let's say, these n integers, now number of subsequences of that specific array, number of subsequences of that specific array, again mark my words, for that specific array, let's say name this array a as a, I named this array as a. For that specific array a, number of subsequences of this array a is nothing but the power of a. So power of an array of integers, let's say here the array of integers is a, is defined as the number of subsequences with their sum equal to k. So number of subsequences of the array a, again let's write a bit clearly, array a, but a bit condition that sum should be equal to k. Okay, remember this part. It's a very important thing, just so as you can understand the problem statement. As soon as you understand the problem statement, I swear I'll make it like a butter for you. I don't know if you like butter or not. I don't, but yeah, that's how we have to make it. Now we have to return the sum of power of. Again, remember, मकसद नहीं बोलना. Power is nothing but number of subsequences of an array. Again, specific array where the sum is equal to k. I have to return the sum of power of all the subsequences of nums. So from this original array, now name this array as nums. From this original array nums, I will make the subsequences of this specific nums. Okay, one such subsequence can be, let's say a, where I have, let's say, 3 elements. Other subsequence can be, let's say b. Again, I am saying array b, where I have, let's say, these 3 elements. Or maybe again I can have a subsequence C where I have these 2 elements. I can have a subsequence D where I have, let's say, 1 element. Again, I have left the spaces for you to understand that okay, you can have other also, but you are taking subsequence. So these are possible. Again, they can be possible subsequences. Comment down below, what are the number of subsequences in an array? How many number of subsequences will be there in an array? Comment down below right now. Okay, Aryan. So what will be your answer? Your answer is the sum of. So what I will do is I will take and grab the power of a. Now understand this. Power of a was number of subsequences of array a with the sum equal to k. Now I'll grab the power of b. Power of b is number of subsequences of b, of the array b, with the sum equal to k. Now I'll get the power of c, which is number of subsequences of array c with the sum equal to c. So you saw, I grabbed the subsequence out, that became a new array for me. From that new array, I'm actually deriving and like getting the power for it. And power formula is nothing but number of subsequences of that input array, which is already for us is actually a subsequence itself in the first place, and then grab those number of subsequences from the array a whose sum is equal to k. Now, considering that now you have at least understood what the problem was trying to say to us. For an example, again, we will not go into the entire complex example because it can be very complex for you, but just an example, I'll show you that for this nums array, I will draw 2 subsequences. Okay, again, there are multiple subsequences possible, and I have asked you to comment down below. So let's draw 2 subsequences. Again, subsequences, sequence elements you grab out in an order. Next question for you to tell in comment section is difference between subsequence and a subset. Comment down below right now. Now, imaginary, I grabbed 2 subsequences out. Let's say my first subsequence A was having all 3 elements. Again, it's valid subsequence. Let's imagine my next subsequence was having just 2 elements. Okay, now I ask you, number of subsequences of this array. Again, now imagine there's a new array. For this array, number of subsequences whose sum is equal to 3. So you can say, Aryan, I can simply say 1, 2 is one such a subsequence whose sum is equal to 3, and 3 is one such a subsequence of array A whose sum is equal to 3. For this, similarly, I can say for this array B, one such a subsequence can be 1, 2 whose sum is equal to K. And you will see that's it's the exact same reason. You will see that your 1, 2 is contributing twice in your answer. 1, 2, 1, 2. Again, 1, 2. It is 1. Again, 1, 2 is just one subsequence. But by the formula which you have built, which means you have to take the summation of number of subsequences of array, let's say X, where X is from A to Z, or let's say A to A dash. Again, this count will be depending upon, okay, now how many subsequence we can have. So for that array X, and then just a condition where my sum is equals to K. Sum is equals to K. This is you have to grab out. And you saw that because of the summation, this subsequence 1, 2 was being counted twice in your answer. And you can also see that this subsequence 1, 2 is counting like one time here and one time while it had all three elements. So, okay, now you understand the problem statement itself. Now, coming on back and breaking it down. Now, this is very complex. I have studied very basic thing. I have studied how I can find the number of subsequences of a problem. If I am giving an array A, I can if I have an array, I can easily find the number of subsequences of that specific array A. If you don't know this, then your DP basics or your basic DP problems, you have not seen it. Although even if not, no worries, we'll still tell. See, what is a subsequence? An element can be either taken or not taken, which means that's in the beginning I told you how many number of subsequences can be possible. So at every location, you will ask an element, bro, can I take you or should I take you or should I not? So I have two options. Either I can take one or I can ignore it. Take two or ignore it, take three or ignore it. So number of subsequences possible can be 2 raised to power n. Okay. So what you did actually, you actually took it or you ignored it, which means you did not take it. And that's again, whenever we take, not take, 0, 1, take, not take, whenever this kind of thing comes, we for sure know it's a DP problem, right? Okay. So now we know that we have to generate, or basically not generate, but get the count or the number of the subsequences. Again, to get the subsequence, I know I can just simply apply take, not take. I have to add a where condition. As in a SQL, you just write a where condition. Similarly, in your programming, you can just write a if condition that, okay, if your sum is equal to K, then only it is a correct answer for you. So how can we do it? Simple DP, take, not take, which means you will have two options with your DP. Okay. One option is take it. When you take, again, just imagine what all what all parameters are required, all that stuff will actually can easily be derived what you want. So if let's say you have, let's say A, your array A had these three elements. So for this, you have two options, take, not take, but you have two options at that index. So for sure, right now, I need to be at that index. So index is one thing I require for sure. So, and that's a very basic thing in any problem. They have to iterate on the array. Index is a first priority. You have to keep track of at what index you are. So index is one thing I need in my DP state, or basically in my recursion. Main thing is again, don't forget what you have to do. You have to verify in the end if your sum is equal to K. So you also will have to maintain what is the current sum so far. If you take this element, then the sum will be increased. If you ignore this element, then the sum will remain same. So this is what I want right now. Maybe in future I might figure out, okay, I need something else also, but right now these two basic things I know I need to take for sure. Okay, so what I did was, if I take something, then okay, I take it. When you take something, then why you did not increase the count and all that stuff? Yeah, bro, that is okay. I did not increase the count because I did not increase the count because I can only increase my count only when my sum is equal to k. I can only increase my count only when my sum is equal to k. So I can only increase my count in the super end. I cannot increase my count right now. I can just try for multiple possibilities right now, but I cannot increase my count. So when I say I'll take something, I will simply say, okay, I'll take it and I'll move on to my next element. And when I take it, the impact will be not outside, but actually in this function itself, where your sum will actually increase. Right? And if you not take something, okay, you will simply again move on to the next index, but your sum will remain stagnant. Now, okay, that's a simple recursive case which you have to write to get to know number of subsequences. Whose where is this whose sum is equal to k? That condition you never told. Yeah, bro, that's correct. So we'll simply say in the end, or basically whenever I'm coming on in my actual function, as you can see, solve is a function for us. Again, int, like you can put solve. As soon as you entered inside this, sum is equal to k, you have got, bro, one good subsequence, and you can simply return a 1. And very basic stuff, that if anyhow you reach your index out of your end limit, then you simply return a 0. Now you know that if you will not use memoization, then you will actually be going on to 2 to the power n states. But you can simply memorize that because you know you have just 2 states, your I and your sum. So you can just memorize that I and your sum, you can memorize that, and thus you can simply say, bro, that's my answer. So for you, ultimately in the end, you will have to return the number of subsequences. Again, remember, number of subsequences. So it can either come from take or not take. Maybe you have taken an element or ignored an element. Anyhow, you want the total number of, so I just added both of them, total number of subsequences possible. Now, this is a very basic piece of code, which gives you the total number of subsequences of an array whose sum is equal to k. Okay, but you'll ask, Aryan, what's the time complexity of this? So the time complexity of this, as you can simply see, is I, which is nothing but n. You have n elements indexes, you have n indexes you have, and then the sum. Now make sure, again, people will just tell, like people in the YouTube will just teach you, okay, this happened, but make sure the time complexity for this right now is n into sum. Now make sure n into sum, make sure one thing, this sum is nothing but sum of n elements. This sum can be pretty large, although in a DP you have seen, again, it's a big red flag like your X. So it's a big red flag for you to just make sure, okay, bro, the complexity is n into sum. There's a high chance this can give TLE, because sum, it usually end up going very large. Some end up going very large. For example, if you had not watched the 100 days 100 placement challenge day 22, we have discussed a problem, partition array into 2 arrays to minimize some difference, in which, if you remember, we actually went on and again, subset and a subsequence more or less are same. It's just that subsequence is ordered, while subset you can take any of this. So in that, we figured out the space and time complexity is O of sum into n. Now in a usual DP, which is the very basic DP, it can end up working, but for this specific problem, the sum was pretty large, and that usually can happen. So in that, we again, you remember the sum is 1e8. So in that we learned, okay, we have to use another hi-fi technique, which is meet in the middle. So it's the reason we learned in this specific problem, we learned meet in the middle algorithm. But now we can't just directly go and apply meet in the middle. It's very long. Like you have to go, you have to do many things. If you have watched this video, it's a like 1 hour video. So you have to do many stuff in meet in the middle. So it's not easy actually to do. So Aryan, is it hard problem? Bro, just do one thing. Check what is your sum limit. So bro, Aryan, as you told that, okay, if my sum is equal to k, then I will return a 1. Then I just don't want, if my sum becomes more than k, then I can simply ignore it. Yeah, bro, that's true. So I can simply say that, okay, just a or condition here, that if my sum becomes more than k, then also I can simply return a 0. For me, it's not required. I just only require when my sum is equal to k. Aryan, so can you also ignore your sum less than equal to k? Like less than k also? Like the way you ignored more than equal? No, bro. I'll not ignore less than, because I still have a chance that it can become equal to k, because I'm adding stuff on it. But if it has become already more, I cannot decrease it, because I know one thing for sure. My all the elements are positive. So I can never decrease my sum. I can always increase. I can never decrease my sum. So I know one thing, that I can limit my sum to k. So now instead of saying my complexity is n into sum, I can now easily say my complexity is n into k. Now go and check what's the k value for you and what's the n value for you. N value is 100. K value is 100. So bro, that's so good for me. Now again, remember, that's a part of a question. For me, number of subsequences will be, to find out number of subsequences whose sum add up to k, that complexity will be n into k for me for this question right now. Okay, so complexity will be n into k. That made things very, very, very easy for us, because you saw both n and k are 100, which means I can write as much untidy code as possible and still it will work. Right? Again, we will not write it, but yeah, I'm just telling you that things can go very easy, very easy. They have given the entire limit for you. Go try anything you want. So, okay, Aryan, that seems so great. Like, are we done? No, bro. What you found out was number of subsequences for a specific array A. But if you remembered that in the question, you have to find the number of subsequences of all the subsequences itself. Aryan, it seems to very confusing, like how I will go and find subsequences and then go and apply this algorithm. I know the subsequences can be 2 raised power n. So are you saying go on to all the subsequences and then apply a O of n into k algorithm? No, for sure this will give it to TLE. So Aryan, what to do now? Simple, bro. What you saw in the beginning, I told you that, okay, consider 2 arrays. Again, we just consider 2 arrays and then we'll try to see what we can, again, ignore, it's too hot. It's too hot. I know why in Bangalore it's too hot, but I'm just sweating right now. Cool. Now, what happened is, again, the fan is on, so no that thing. But yeah, so you saw in the beginning, I told you, like, okay, imagine 2 subsequences. One is 1, 2, 3, other is 1, 2. So you saw this 1, 2, 1, 2, it summed up to k, and that 2 it was repeating twice. Now, if I want to find out, okay, Aryan, I can know for a specific subsequence, which is 1, 2, again, forget now these two. Consider only the specific subsequence 1, 2. Again, I am saying that will be very confusing for you, that one array can have multiple subsequence. Now in this question, for one subsequence also I am getting multiple subsequence. Now I am asking you that, bro, ignore the middle portion. Focus only the last subsequence made. So focusing only the last subsequence made, which is, imagine in this case as 1, 2, and I can simply say for this array nums, I ignored the middle portion and I went on to last portion. This 1, 2, this is one such a subsequence. I just have to get to know how many, what is the count, because you saw that one such count was here and other was here. So I just want to know ultimately how many such subsequences I will form for one subsequence whose sum is equal to k. That's my task, so that I can simply get to know that if this subsequence is occurring, and if it sums up to k, then instead of returning 1, if you remembered, instead of returning 1, say, okay, I have got one subsequence, I will return a specific value x, okay, that I did not get 1, I get x. As you can see, x here is 2, so I got 2 such subsequences. That's how I can go about. Now this can be pretty complex, but we are not that complex. So what we can do? Again, we'll not go very deep. We'll simply imagine what is happening. So if I take, let's forget this. Okay, let's say we had n elements. Okay, 1, 2, 3, 4, 5. Imagine you had 5 elements. You saw that your k was a 3, right? Your k was a 3. So you got to know that, okay, 1, 2 as one subsequence will for sure give you a sum of, give you a sum of 3, which you required k. It gave you a sum of 3, which you required. Now what? Like, Aryan, you forgot the main maqsad. You forgot the maqsad. Maqsad was that you have to get to know how many times this 1, 2 can occur in total. Which means this 1 2 is one subsequence which I have found its sum up to k. So it will for sure come, because I am right now finding it for this 1 2 only. Remember, I'm right now finding it that this 1 2, how many times it will occur. So I'm just saying right now this 1 2 can again, okay, for sure he will come, because I am right now checking for this only. So 1 2 will come. Now for others I have option. Either my 1 2 can come alone, either my 1 2 can come alone, that's valid option. Again, the sum comes to the sum adds up to k. Or my 1 2 can come with the number 7, or my 1 2 can come with my number 6, or my 1 2 can come with a number both 7 and 6, or my 1 2 can come with a number 4, or my 1 2 can come with a number 6 and 4. So you saw that for others again, right, make sure one thing, 1 2 you are taking right now, because the answer you are finding, it is for 1 2 as one subsequence, which is a good subsequence for you. You are trying to find how many times this subsequence can occur. So we got to know that, okay, 1 2 for sure I have to take, okay, this will for sure be taken, right, only right. But for others, I can just skip them. I can take it or not take it. Same way, I can take it or not take it. So if I can get to know, okay, count of elements I have taken are 2, total number of elements I had were actually 5. For remaining 3 elements, which is 5 minus 2, for remaining 3 elements, I had 2 options. Either I can take them or ignore them. And as you can see, I can make these 3 arrays. So I have 2 options. Either I can take them or ignore them. So total number of subsequences where 1 2, I'm only talking about 1 2, where 1 2 is the BAP, is actually 2 raised to the power 3, which is n. The n was 5, remember, count was 2. So it will be 2 raised to the power 3, which is where this 1 2 was the BAP. So now if you forgot that we were actually returning this value 1, okay, 1 2 as one subsequence, okay, we have got one subsequence, one good subsequence, we simply return the 1. But now in this case, that 1 2 is occurring in 2 raised to the power n minus count. Again, count is the number of elements in that specific subsequence whose sum add up to k. So that is I will return instead of returning 1, because this is actually the count which this specific subsequence 1 2 is returning or actually impacting. So if we go by this existing example, so you can simply see 1 2 3, this 1 2 as a subsequence, this will for sure be taken, for others, which is 3 in this case, it can taken or not taken, ignored or taken, like taken or not taken. So I can simply say the impact for this will be 2 raised to the power, again 2 is for take not take, that is the option, raised to the power 3, which is all the number of elements, which are 3 in this case, minus the count of 1 2, which is a subsequence I have taken. Again, right now remember that 1 2 is I am fixing on that 1 2 minus 2. So it gave me 2 subsequences, and you can for sure see, I showed you also one such a subsequence. Again, where is that gone? One such subsequence was 1 2 when it was actually alone, and 1 2 when it was actually with 3. So here you can see 3 is missing, 3 is taken, and that's how this specific contribution of 1 2, you got to know that it will be nothing but 2 raised to the power total number of elements, which is n, minus the count of elements inside this subsequence. That's the final thing which you have to do, which means in this final thing you have to just modify this one thing and return this value, which is 2 raised to the power n minus count. Aryan, that seems so good. So is it that okay, my answer is, and I can simply, bro, you forgot one thing, that in your existing code there was no variable called as count. In the existing code which we have written, there's no variable called as count. So we have to just add one variable, one other parameter called as count. Either we can find a hack for it, but we saw that we have a lot of luxury for it, so we don't need to find a hack for it. We can just simply keep track of the count, because count itself can be at max how n can go, right? And we saw that n is very small. So very easily we can accommodate count also with us. If it would have been a worst case, which means okay, if it is about to pass, not about to pass, in that case we might have think of optimizing it. But right now we can always think like, okay, count I can easily pass in, and as soon as I take an element, I take an element, in this case, I take an element, I will increase the count because I have taken something. If I don't take an element, I'll keep my count same as it is. And this is the only modification you need to do in your existing code of DP. Cool. Let's see the code. It's pretty easy. Again, if you don't know one thing, which is binary exponentiation, please go watch this video of our maths and number theory. Aryan, but why do we need binary exponentiation and that stuff? If you don't know, in the code, you have to find 2 raised to the power n minus count. Remembered? This is, and you saw n can be 100. So 2 raised to the power 100 can be a very large value. In these cases, the problem always asks you to, bro, please return it with a modulo so that it never exceeds a specific value. So you have to do nothing but 2 raised to the power 100 mod of this mod value, which is 1e9 plus 7. Which is 1e9 plus 7. You have to do a mod with this value. So this operation is nothing but binary exponentiation, and you should be knowing how to do it. If not, please go and watch this video. I'll not explain in this video at all. Now, coming on back, how the code will look like. It's pretty simple. That firstly, we have the code for power, which is binary exponentiation, which actually work in O of log n time, because you see, we are doing half of n at every step. Now comes the main code for us, where we actually have a DP. You remembered, in a DP, we will actually, again, whenever you write DP now, firstly, always write your solve function, DP function, recursive function, right? So in that, you remembered the simple thing. If your sum reaches equal to k, then return 2 raised to the power n minus count. When your sum reaches k, return 2 raised to the power n minus count. In other cases, when your sum is either more than k, again, please make sure to put this condition of sum more than equal to k, else your sum will keep on increasing and it can become out of your k limit, right? Don't let your sum, which is more than k, come onto this DP value, because your DP can only accommodate limited values. If your sum will keep on increasing, your DP will demand more space, and that you cannot give to your DP. So please, that's not required for you. Just get rid of him in the beginning itself. So again, you can either put this if condition also clubbed with this condition, or you can also put it differently, like how I just took it. So I just wrote it like this. But yeah, both these conditions can be clubbed. Bottom, again, don't club this bottom with up, nah? Because if something is equal, then firstly I have to check if sum is equal. So this is the first condition I have to check. Then if sum is more than k, or if my I is actually more than equal to my nums, which means n, I can simply return a 0, which means no subsequence I have found. Now, when this is done, a simple Riti for us, Riti as a ritual for us, that DP, memoization, I, count and sum. Again, all the parameters I need I, sum I need earlier, count is new thing which I have added. So I need I, count and sum. Again, take not. Again, I have taken everything as LL. Not required, but I always prefer to be on safe side when I handle modulo. So take, okay, I plus 1, count plus 1, sum plus nums of I, because you are taking an element, so sum plus nums of I, and then okay, rest of the parameters are as it is. Same way, if you not take some element, then okay, I plus 1, you will still go on to the next element, count will still remain same and sum will still remain same. Now the total number of subsequences will be nothing but the total count. Take plus not take, add them. And also don't forget to memorize that. Now ultimately you will see the time complexity for this. Nothing, again, the code is done. Just simply initialize your DP with the -1 value and simply call your solve function with saying, okay, index is equals to 0. Initially my count is also 0 and my sum is also 0 initially. And that's how you can simply solve it. Now you saw the time will be O of n into count into space, sorry, n into count into sum, n, which means I. If you remember, I is nothing but bounded by n. Count number of elements can be also bounded by n. Sum was bounded by k, I have told you. So my complexity will be nothing but n into k, which is n square into k. Again, because of that binary exponentiation, my log and factor will come in picture, but that too is very negligible for n equal to 100. So you can also ignore that, but still, if you want to write it, you can write it also here. But still, this will for sure work. It will for sure pass. Because the constraints 100, which means right now the complexity is 1e6 into log 100, which will for sure pass for us. For sure. And the same way, space will also be O of n square into k. But can we improvise it? We can, because we saw that count was something we might not end up requiring, right? Because we have done DPs, and why not? So what we found out was, okay, we were grabbing, again, I will take the exact same example. We were grabbing a subsequence 1 2. For that 1 2 subsequence, the impact of the subsequence I was finding as 2h power n minus count, right? Okay, great. That's the count which was the issue for me, right? This was the extra thing which was the issue for me. Can I remove it? Okay, before removing, you have to find out any other way that you can replace your count. Okay, let's see. So what was happening? So this count which I did, and as I showed you, it was counting twice because of this and this. If I give a very generic example, let's say again, I would take the exact same subsequence 1 2. Again, like, please forgive if I have spoken sub-array anywhere previously. It is always subsequence. Now this subsequence 1 2, again, I'm talking only about 1 2 right now, and I'm telling the impact of only 1 2. So I will for sure take this, and for the remaining ones I can either take or not take. That's the reason I just grab the value of n minus count, which is the remaining elements, and this I will take for sure. So it's a right. Further, it's a take not take, which is optional for him. So for everyone I have two options, so it will be 2h power n minus count. That's how I grabbed it. Now if I ask you, I had the exact same stuff here also. Again, remember, it was a subsequence, so this 1 2 will for sure be taken, so it's always a right. Now, as you remembered, whenever something is taken, okay, let's say your index, again, you have to remove count. Remember the fact, you have, again, right now your elements or your parameters right now you have is I, count, and sum. You have to remove count. So instead of using count, you have to use either sum or I, something in replacement of it, so that the formula which was existing made as 2 raised to the power n minus count, you can replace it with something, maybe something else, but using these parameters only. That's your aim. Maqsad nahi bolna, right? So what happened in this is that as I'm keeping on moving as I keep on moving on my eye, okay, my eye is moving, because you keeps on moving your eye. Now, when your eye is right now here, again, your eye has reached here. It has not evaluated this. It has just reached. Okay, evaluated portion is this left portion. Your eye has just reached here right now. If your eye is reached here, so you can simply say, Aryan, I can simply say na that these are n minus I elements, because you can see n is 5 here. My I is 3. My I here is 3. So I can simply say these elements are n minus I elements. So I can simply tell Aryan, see, answer will be 2 raised to the power n minus I, because simply not take or take for both of them. For these two elements, take not take. I can say that was okay, but you saw one thing, your n minus I value is nothing but 2, because it is these two elements only. But if I have asked you what was the count value, what was n minus count value, it was 3, because this 4 also had a possibility of take not take. That's an issue. Because if I tend to use my I now, right now, then I can accommodate all these remaining end values, but the ones which I have not taken, because you saw na, these 1 and 2, this 1 and 2 is for sure, again I'll change the color, this 1 and 2 is for sure taken, but the one which is not taken, that are getting missed. What is getting missed for them? The thing which is getting missed for them is the factor or the multiplication by 2, because they are one which actually we ignored them, which means they are not necessary for us to take, that which we ignored, as in, okay, take not take wala options, that a factor of 2 is getting missed. If this factor of 2 would have added in my existing this answer into 2, then it would have been exactly same as that of n minus count, which is my 2 raised to the power n minus count. So you saw anything which was ignored, that will contribute a factor of 2. So come back on your code and say, bro, anywhere I will not take something, I will just multiply that by a factor of 2. That's it. So what I ended up happening is, okay, bro, I'm not taking this. Okay, if where's your, yeah, I'm taking this. Okay, nothing. I'm not taking this. Multiply my answer by 2. I'm taking this. Nothing. Okay, Now I am trying to evaluate, okay, is my sum so far is equal to k? Yeah, it is equal. Then my answer will be nothing but 2 raised to power n minus I, which is this specific number of subsequences multiplied by 2, which I have been doing it so far. And that's how I can actually, I don't need to check what is the count of elements. So I did I did exact same stuff. The only change in the existing code is multiply the thing by 2, and here instead of taking n minus your count, you will take n minus I. That's the only change. But Aryan, still your count is here, still your count is here and here, still it is same. Bro, it is not useful now. So I can simply ignore it. I can simply remove it. So now I simply removed everything of count. Everything of count is removed. And the only change I did was n minus I and also 2 into I. And that's it. And because of this small change, you have optimized your time from O of n square into k into log n to n into k, because now your only state is I into sum, which is n into k. And thus your time is O of n into k into log n. And the same way your space is O of n into k. And that's how you can simply solve it. Cool. Thanks for watching. Bye. Take care. Bye. I know it's a bit long. I know the video is also late, but today I'm done. Today my head is gone. So yeah, bye bye. Take care.